So, good morning, everybody. I am going to present the results of a collaborative study that we are doing in pine oak forest, and in this case, showing some results on the thinning effect. So, we choose this species mixture because it's a relevant and important mixture in Europe, especially under climate change. In previous analysis that we did using a triplet transect across Europe, we found that that there is overyielding, that is more productivity in mix than in pure stands, but there was a large variability between sites, as you can see in the figure. That is the relative productivity of the two species, and you see that in the sector one the two species benefit, but there was some variability among sites. But we also find, using this transect, that the susceptibility to drought was lower in the mixture than in the pure, and that the temporal stability of productivity was greater in the mix than in the pure. So we have some benefits when we mix these two species. But however, there is still scarce information about how to manage this mixture, and for this reason we start this study that we compare the thinning responses in mixed and pure stands under similar site conditions. In this presentation, I will show the results at three levels. So that is the effect on tree growth and on tree mortality. Well, you already know what is a triplet. Our experimental design was choose 8 sites of this transect of pine oak triplets across Europe, and at each site we established 2 triplets, and within one of them. So at each site we have these 6 plots with pure and mixed stands and thin and unthin stands. We applied heavy thinning from above, and you can see the thinning weight that we will use later in the analysis are between 36 and 42% of basal area removed in the thinning. And the results are based on 2 inventories with a 5 years interval. For the analysis, we model the tree growth depending on the tree size, and we use the basal area of the tree and the basal area growth of the tree, and the thinning weight to express the thinning effect. And we explore if the thinning response is different for different tree social classes, as we are applying thinning from above, so we expect some differences. And for this we use this index, that is the basal area of larger trees. So the greater the basal area of larger trees, the more suppressed is the tree. And also we explore if the thinning response is different in mixed and in pure stat. That is our main question. We also consider other interactions, but to simplify, this is the general model. And well, there is a mixture in the but this U is the random factor that we consider also different structure of the random effects, but simplifying that, we consider the site as the main random factor. And for the tree mortality we use the same structure, but only using the logistic regression, because it is due to the nature of the mortality variable. So if we go to the results, focusing on tree growth, for both species, there was a positive effect of the size, so the greater the size, the greater the growth. And we found for the two species that the interaction between the thinning and the social position of the tree was significant. And you can see below, in the graphs below, for the two species, that the thinning reaction was stronger in the dominant trees. That is what we expect with thinning from about. And that the effect on the suppressed trees was small, and it was similar in the two species. But focusing on the mixture effect, we found that for pine, there was not interaction with the thinning, but the growth in the mixture was lower than in the pure. That we also find similar results in other studies. But for oak, the growth was greater in the mix than in the pure, but especially if you think the growth is increasing so the effect of the thinning is greater in the mix than in the pure. Focusing on tree mortality, so the main factors explaining the tree mortality were the tree size and the social positions. So the larger the tree size, the lower the mortality, and the larger the basal area of larger trees, the greater the mortality. But we also find some mixture effects, and again there were some differences between the two species. For pine, we found that there was a positive effect of the mixture, of the interaction and mixture and thinning. So the mortality was greater in the mixed stand than in the pure, but if we thin, this effect disappears and the mortality is lower. And for the oak, we found that there is not, so potentially there was not effect of the thinning, so the thinning was not similar, but the differences were not statistically different, but there were an effect of the mixture, and the mortality was a bit greater in the pure than in the mix, but again the variability was very large. So we can say that if we mix these two species, we can say that the mixing species increases tree growth for oak, but reduce the growth for pine, and increase the mortality of pine. So oak benefits in mixtures at the expense of pine. So this is not an unstable mixture. These results are similar to previous studies we did with pine beech transects, where we also find that the mortality in this case was expressed by a volume. This dropped up, but you can see that the pine and in this case both species mortalities are higher in the mixed stand, but especially the pine mortality was greater. And it has some impact on over-yielding, because we found that in this mixture of pine and beech there was over-yielding, but if we analyze the net growth, that is, if we remove the mortality of the productivity, in this case there was under-yielding. No? And what we learned from the thinning is that if we do thinning, heavy thinning from about in this mixture, it increases the tree growth for the two species, but mainly, of course, of the dominant trees, and reduce the pine mortality in mixtures. So thinning are needed if we want to control the species composition and maintain the mixture. And this explains the results we found with these plots at the stand level, that there is a loss of productivity when you thin. That is what we know from pure stands also. But if we analyze the net growth, you can see in the right figure that is green, light green a line that is the mixture, that there is an increase in the net growth. So we have some benefits when we thin the mixed stands, in this case of this mixture. And also has agree with the stand level results with over-yielding, and we see that for both using gross growth and net growth, the over-yielding was greater in the thin stands, and especially the net over-yielding when we remove the mortality. What we are doing is we avoid under-yielding in the mixture. So thinning in this mixture enhance the benefit of species mixing and help us to control the species composition. And also another conclusion is that it's very important to consider the mortality when we analyze species interactions and mixing effects. So thanks. I want to thanks to all the people who contribute to this study with all the triplets, and especially I want to use this day that we are meeting here due to the Hans nomination for Dr. Honoris Causa, to thank him for initiating this triplet transect and for all the nice collaboration with this since we started to work together more than 10 years ago. And just to remember your first visit to our forest in 2013, so we can do the questions with the speakers. So thanks, guys.